Welcome. So today we are going to cover a few things. As I probably have mentioned before, I'll record the videos in small short segments, and each lesson will cover a different topic, so you can jump around and view videos as per your convenience. So the first thing before we begin, I want to introduce Google C++ style guide. The link to the style guide is on Moodle, and the style guide is essentially some of the styling, naming conventions and standardizations that Google employees follow for writing code for Google. And some of the things I would like to adopt because we need to have a common medium of communication, like a language. So when we write code, we want the code to be easily readable to others in the team and in the organization. So therefore it's nice to follow some standards, and this is a nice standard to follow. It's not perfect, but it works. So in the Google C++ style guide, jumping to naming conventions for now. So naming conventions, you probably have seen this in Java also, that type names, which means classes, usually start with the uppercase. That's the convention. Compiler is will happily accept anything, but we prefer class names to start with the uppercase. And for variable names, then variable names usually start with a lowercase, so that we can distinguish between what is a variable, a data member, as compared to a class, a type. Now within the class members, there are maybe instance variables. Now you know the difference between instance variables, where each variable belongs to individual object, versus a class member, or sometimes called a static member, which belongs to a class. We will talk more about that later, but for now we are mostly focusing on instance variables. For example, in this case, the car class that we created last time, we have 3 instance variables: year, make and model. So I'll just write this comment here, instance variable. And so for the instance variables, or the members that belong to a class, the Google C++ style guide says that we usually have a trailing underscore at the end, which means like this. Here you can see trailing underscore means we can see that by seeing a variable, seeing a variable, we know that this is a variable that belongs to an object, or it's an instance variable or a class variable. So in this case, I have adopted this convention here. So on forward, I expect that all of you also use the same convention. In every class, the variables, instance variables, have a trailing underscore. Okay, so now of course this makes our CPP file, we'll have to change, because here we need to change this to make, model and year. And also in the constructor we need to change this, so that we are following, we are actually referring to the instance variable. Okay. Now another thing before we move forward with constructors is accessor and mutator methods. We have done this in Java and C++ also. Sometimes it's easier when we create the accessor methods and mutator methods to not have get and set words in front of them. So a lot of code you may have seen, Qt follows the same convention, that if I want to make accessor method for, let's say, make and model, so it's going to return a string, and we will just say make and parenthesis and semicolon. So this method is going to return make and then string model. So whenever we need to see make, we can just call this method make. So the variable name, instance variable name, and the accessor method for make have same name. Okay, so let me write the definition of this function. So we just added a declaration. We talked about declaration and definition earlier. So this is return make, and going back here for model, refactor, add definition, return model. Okay, I'll also add the comment here because it's good to add comments as we go along. This is not required in this case. It's a very simple method, but it's nice to get used to writing comments as we go along, as we write code, because writing comments at the end is not the best idea. You know that. Okay, so this is accessor method. Let's talk about mutator methods. Now actually we can overload a method, as you know, that if I have a method with the same name but that takes a variable as a parameter, then we know that we can use this, we can have a method with the same name make. The difference is that this method is the mutator which takes a parameter. So mutator method make, and then same for model, string model. The good thing about this is now here this is a local variable or the parameter that's passed to the method model, and the instance variable model, they are different. So I'll show you this in the definition. So let me add the comment here first. Mutator method for model. So let's add the definition in car.cpp. Excuse me. So now we know that the make underscore, make with a trailing underscore, is the instance variable, and make is the local variable without a trailing underscore. So we can have the same name or similar name to the parameter, but we can still distinguish between the local variable and the instance variable. So that's the benefit of following this convention here. So also that way we don't need this. You remember, we could also do it this way, this dot make equals make. So we'll talk more about this later. You have seen this in pointers. This is an implicit pointer that's passed to every non-static method, so that this is pointing to the object which called this method. So if you pay attention to what I said, this is an implicit parameter to every non-static method, and non-static method means the method belongs to an object, not to the class. So therefore whenever a non-static method is called, it's always called in reference to a specific object, and so we need to know which object is calling the method, because there may be many objects of the same class. And so this is the implicit parameter that refers to the object, or that points to the object that's calling the method. So for now I'm going to, I hope that makes sense, this pointer we are calling the this dot make, and because it's a pointer, we that changes to an arrow, and we are referring to the instance variable make that this pointer is pointing to, and we are assigning this. So line 42 and 43 have exactly same meaning, and I'm going to delete line 43 for now, or actually I'll just comment it so that you can you know that it's there. Okay, so that's about the mutators. Let me add the mutator for model. Again, the same thing. We have the mutator for model, and the instance variable has a trailing underscore, and we assign the parameter model to the instance variable. Now, important thing to note here is that the initialization list that we talked about last time, as we see here in line 17, this doesn't apply to mutator methods or to any other methods. It is only useful with constructors. So initialization list, where we use the variables, and in parentheses we use the values that is used to initialize the instance variable or the data member. We cannot use it in mutators or any other methods, so it only works with constructors. So that's one thing. Now we are going to revisit the mutator and accessor methods later on, and we will add const to those, making it a more standard. For now I will just leave the accessor and mutator methods like this. So we talked about the Google C++ style guide. I will refer to a particular sections in this that we need to follow, and for now naming conventions and comments. So that's all we are going to follow for now. So you can see here there is a section for naming conventions here, and then a section for comments, how to write comments. So we are going to follow both of these for now from all of the Google C++ style guide. Okay, going back to the code now. So now you know that we have we created a car object, and then we have c.print. Print is a method. Just to recall what it does, it just prints the information about the car. So car is this make, this model, this particular year, and when we call the method we get the output as here using the default values. Oops, sorry, it's running another code, so I'm going to okay. So car is Toyota Camry, year 2015. That's calling the default constructor that we created last time. Let me show you the code just to recall what we did here. And also so we don't see this line because we have put it into the debug conditional compilation. If debug macro is defined, then only this line will compile, and up here we undefined debug macro, so we don't see this output. So now I'm going to actually define it again just so that we can see the constructor being called. So now it shows default car class constructor called, and this is the output of the print statement. Car is Toyota Camry, year 2015. So I hope everyone is following so far, and let me know by email or by your YouTube comments if you have any comment about how the recordings are or how the class is going. So I'm looking forward for your feedback. Now the third thing I want to do today is I want to talk a little bit about how constructors are called. Right now we only have one constructor, the default constructor, which takes no arguments, and there are three different ways we can create an object. Okay, so this is one object, one way we have seen car C. It creates an object car C, and the scope of this object is this block. So as soon as we exit this block, the object is destroyed. So that's the most basic way. Now there is another way we can create an object, which is using pointer. So if I have a pointer, car pointer, that's a CPTR. Now we know that this on line 8 we have a pointer which will point to a car object, but we have not created an object yet. So we could say CPTR equals new car in parentheses. So now we have a dynamic object. So dynamic object of car class, and this dynamic objects interestingly will remain until we actually explicitly delete this object. So you know that we have talked about memory leaks. So every time we use new, we need to have a delete corresponding to it so that we know that we have deleted the object. So delete CPTR. I'll show you later on a little bit more details of destructors, where we have talked about constructors, but we can also create destructors which do some cleanup. We normally don't require destructors because we know that simple objects, which are we will talk about these deep objects that contains pointers and dynamic objects, those need some cleanup. Simple objects that have only data members such as this, they don't need destructors because these variables will be deleted as soon as we delete the object, so we don't need a specific destructor. So we'll talk about that later. So for now, here we have, this is another way of creating an object. Of course, this is a dynamic object. It has a little different properties. The object remains beyond the scope of the block in which it was created. So even when we exit this block, we will have this car object remain until we delete this. So we have to always remember that. Now the third way of creating an object is this. Let me call it car C1 equals car. So now this looks a little strange, but it's actually okay. This is the same thing as doing car C. We are creating a car object and then we are assigning it to C1 or creating the object C1. This is a little different way to call the constructor, and I'll show you later on how the copy constructors work. And but for now, this is okay. This is the third way of creating an object. So let me run this code. You will see 3 objects getting created, and we can see this by default car class constructor called, default car class constructor called, and again. So we have created 3 objects, and these are 3 different ways: 1, 2, and 3. Maybe I should just put a just for symmetry, I'll call the print method here, so that we know that we see the output of the print for all 3 objects. So there are 3 different ways. Now there is one way which is incorrect of creating an object. So I also want to make sure that you see that. It may look a little natural to create an object like this, car C, or maybe I'll put C2. But the way this is actually incorrect way, and I'm going to comment this code later on. Incorrect way of creating object. So this is not creating a car object. In fact, there is no syntax error. So the syntax wise, this code is okay. The way compiler interprets this code is that C2 is a function that returns a car object. And so therefore C2 is really not object, but a function that returns a car object. So we can check that if I press C2 dot print. Now this is a limitation of the Qt creator or IDE. It allows this code to be written this way, but when I compile this code, because C2 is a function, this statement is illegal, line 17, and that's what we will get when we compile this code. So you can see when I compile the code, we get a syntax error on line 17 which says request for member print in C2 which is of non-class type car. Non-class type car means car is a class, and this print doesn't belong to car, so therefore we get this error. So remember, this is an incorrect way. If I don't call this method c2.print, actually my code will pass compilation, because the compiler thinks that I am telling that c2 is a method which returns a car object, and so code compiles. But as I said already, this is not creating a object, but it's just creating a method, and so you cannot do anything with the method later on. So we saw that if I call c2.print, we get a syntax error. So I'm going to comment this line also, just so that we are not confusing ourselves. So now we have 3 correct ways of creating an object, and one way which seems correct but it is actually incorrect. So this is going to appear on a quiz, so be prepared. And I'm going to run this code, it builds and everything is fine. Okay, so that's all for this lesson, and I'll talk about a few different topics in the next lesson.